All right, so I'm going to help solve this problem again. So if you're kind of confused about where we are, we're on worksheet 4. This is part 2, so go back to part 1 if you're confused. I like to solve these problems with graphs, so let me do that. Average acceleration, it is this slope here. So that would be, now remember, it's final minus initial over that time span, which will be 14 minus 30 over 6. So minus 16 over 6, or negative 2.67 meters per second squared. So pretty common thing. If you don't draw the graph, I think the graph makes it obvious. Negative slope, I should have a negative acceleration. If you just solve these numbers, you try to grab an equation, you probably would get this problem wrong. And I'll show you, if I were to use an equation, the one I should use is definitely 2. Why I wouldn't use like 1 or 3? Well, first off, I wouldn't use 4. And why would I not ever use 4? Because I'm looking for acceleration, and I need an equation that has at least acceleration. Well, 4 is the only one without acceleration, so that knocks it out. And of these 3, I have the velocity terms and I have time. I don't really have position, which both of these involve position. So that's why 2 would be the best. Now, I'm just going to keep moving because I don't want to take too long on these videos, so you can go back and see what I'm doing on these problems if you have questions. So we have this bear, and he's going to accelerate from rest. So, I haven't been doing this, but let's do the good practice of writing out all the variables I have. A is 2 meters per second squared. Now they tell me the honey's 16 meters away. There's a couple ways I can interpret this. One way is to say that that 16 meters is really the change in my position, which will be 16 meters. Or another way to think about it is the difference between x minus x naught is 16 meters. So the easiest way I can write this is I will make x 16 meters, which would make x naught 0 meters. Now, this is where I tell my students, you have the choice here. You have the choice of, am I going to put these meters like at 100? I put x at 100. That would make x naught 84 meters. Or you could do another way. You could say, x naught's at negative 16 meters and x is at 0. It's up to you. Generally, either x naught or x should probably be at 0. And if you're going positive, keep everything in the positive region, I would say. So they ask us, how fast will this object be going? This bear will be going. They say his snout, that's the bear. Another thing, and I almost skipped it, they give us another information. It starts from rest. Remember, rest 0 meters per second. So my initial velocity is 0 meters per second. All right, so I'm going to use a graph again. And I always think it's good to draw a graph. Now I'm going to draw this graph, and I'm going to tell you, okay, well, I don't have a lot of information. I know it starts at 0 meters per second, but I don't know the time, and I don't know my final velocity, which is what I'm essentially trying to find is my final velocity. Okay, so is any of this other information stored away inside this information? Like, is this 2 meters per second? Where is it in this graph? It's in here. It's the slope. And actually, also the 16 meters is in here. The 16 meters is the area. So this is why I say the VT graphs are the best, because everything should pop up in some way or form in these graphs. Now, I have this graph. How can I solve this? It looks kind of hard. Let me try to use, I have the slope formula and I have a slope. So slope is, in this case, A is equal to delta V over T. Well, I know that A is 2, but I'm trying to look for delta V and I don't know T. Okay, I've run into a dead end, 2 unknowns, only one equation. Well, let me try another. All right, area, which for a triangle is 1/2 base times height, which will be 1/2 times T times delta V. That's going to be equal to 16. Now, if I bring the 1/2 over, that'll be 32. Can this solve each other out? And what I'll tell you is that actually, you can solve it. And if you remember from algebra, probably the easiest way to solve this would be to use substitution. One example would be, this is 2 equals delta V over T. I can say T is equal to delta V over 2, and I can plug that back into this equation and solve it. And I'll probably show you this time, but whenever you run into this problem, this is what I'll say. There is probably an equation at this point. You have so many variables unlocked, you can probably solve for the final velocity with a single one. And if we go to our available ones, let's see, I come back up here. I'm looking for v, final v, so I'm not going to use 1 because it's locked away. I could try to use this one, but remember, we already tried the slope formula and it didn't work out. I have 2 unknown variables. I can try 4, but once again, this is the area formula. It's locked away. And so the last one I will try is equation 3. So equation 3 is this one. V squared is equal to V naught squared plus 2a delta x. Let me fill out everything here. V squared is equal to 0 squared. 2 times my acceleration is 2, my delta x is 16, and I'll get v squared is equal to 64, or that v is equal to 8 meters per second. That's my answer. Would this have got me to this answer? Well, if I were to plug this in, this becomes 1/4 times delta v squared. The 1/4 would actually turn the 16 into 64. 64 is equal to delta v squared. I simplify that, that would end up becoming 8 meters per second as well. So this method works too. So this is how equation 3 comes up. If you remember from part 1, I said I didn't really prove to you why equation 3 works. This is basically it. It is just the derivation of substitution between the slope and the area. And it's useful when you don't have the final velocity and time. So, all right. Y'all should have hopefully been working on the other problems, but if you hadn't, I suggest you work on them now and then I'll go to them. All right, moving on to this next one. We have a bus moving at 20 meters per second, slows at a rate of 4 meters per second each second. All right, so before I even make any graphs, let me solve for variables. I've got v naught. My initial v is 20 meters per second. Remember, that's the most important variable. We're good to go. What else do we have? We have 4 meters per second each second. Initially, this looks like it's going to be a velocity, but it's actually hidden into something else. I would argue that this is actually acceleration. We're slowing at a rate of 4 meters per second each second. Now, you're slowing down, and I said we have a positive 20 meters per second. That means it's a negative 4 meters per second squared, not a positive. If you write that wrong, you're going to get the problem wrong if you try to plug into equations. Now, they don't give us another variable here, but then they ask us how long does it take for the bus to stop. How long? That's a time that we're looking for. And then bus to stop. Bus to stop. Well, let me start drawing my graph now. So I have 20 meters per second. And this slope is negative 4 meters per second squared. So what they're saying is for the bus to stop, that means I'm not moving. So actually my final velocity is 0 meters per second. So this is a case of, hey, they're giving you the variables. In this case, it's kind of hidden in the question part, not in like the intro. So they can hide these variables any which way. Now, for time, how long does it take? Some kids might notice how to solve this. I would say, hey, you got the slope because we have the rise, we have the slope, we don't have the run. So A is equal to delta V over T. This is equation 2. And, that would mean T is equal to delta V over A, or 20, negative 20. So let me back up there. V minus V naught over A. What's going to end up happening is your initial velocity is 20. Your final is 0. So 0 minus 20 over negative 4. This is where if you got a positive or a negative 5 seconds, this is your moment to realize, hey, time probably shouldn't be negative in this context. Can you get a negative time? Technically, yes. It probably doesn't mean what you want it to mean. So positive 5 seconds is what I'm looking for, not a negative 5 seconds, especially if you're using negatives outside of this context. Like if we have double negatives here and I get a positive and it should be positive, that's a good sign I'm probably doing my math right. All right, so 5 seconds, that's part A. I use equation 2 or the slope formula again. And then they ask how far does it travel? Now, at this point, I can use a lot of things. I can take the area, which would be equation 4. And you know what, let's just do that. So either equation 4 or the area, I get 1/2. So base times height, 5 times 20, and I will get 1/2, 2.5 times 20. That's going to be 50 meters. All right. So hopefully that's good. And let's see. One more problem. Let's do, I'll break it off here and then we'll go to the next video. So hopefully y'all feel pretty good about that.